Greetings. In this session, we will go through electric vehicle charging, its technology, its economics, and its business prospects. We will start by discussing the difference between kilowatt and kilowatt hour. These are the two units that are talked quite frequently when we talk about electric vehicles, but are often used in a misunderstood or in a wrong way. Then we will discuss the charging levels, literally meaning the speed at which, the rate at which one can charge a vehicle. Then we will discuss charging connectors, the devices that connect the charging location to the vehicle. We'll go through the cost of the charging. How much does it cost to charge a vehicle for 100 miles, for example? And then, of course, if one wants to set up an electric vehicle charging business, what are the opportunities, risks, profits, and a few other aspects. Kilowatt is a unit of power. It simply means how much energy can flow through a conductor at any given time. Higher the kilowatt rating, more energy can flow through a conductor. So for example, if a charging station is providing 100 kilowatts of power output, the vehicle can be charged at that rate. However, if the electric vehicle itself cannot handle more than 50 kilowatts of power, it will be charged at 50 kilowatts, regardless of how much power is being provided by the vehicle charging station. Similarly, if vehicle charging station can provide 100 kilowatt of power, but there are 4 different vehicles connected to it at any given time, each of which can accept 25 kilowatts of power, each of these vehicles will be charged at 25 kilowatts of power at any given time. Kilowatt hours, on the other hand, is the amount of energy that can be stored in the batteries of the electric vehicle. Bigger the storage, longer it can go, but of course, that also depends on the size and the weight of the vehicle. As an example, a large truck will require 48 kilowatt hours of energy to travel 100 miles. On the other hand, a smaller car will require only 31 kilowatt hours to travel 100 miles. And this is a metric that's used for electric vehicles as an equivalent to miles per gallon for gas powered cars. Currently, there are 3 different levels of charging. Level 1, which is an old system, uses normal household voltage, 110 volts, but can be very slow. It can take up to 2.5 days, 60 hours to charge an electric vehicle. This level 1 is increasingly being replaced by level 2, which is much faster because it uses 240 volts and typically charges the vehicle overnight. And advantage about that is that one can charge the vehicle overnight when the electricity prices are lower than during the day. Then there is a third type of charging, which is called fast DC charging. It uses DC current, which is different from AC current in level 1 and level 2. And the advantage of that is that batteries can only be charged by DC current, and level 1 and level 2 have to first change that AC into DC. So DC current uses higher voltage and DC, and therefore it's much faster than level 2, up to 8 times faster. However, because of the higher voltages used, it's only commercial grade. One has to use much better insulation and for safety and other reasons. And because it can charge a vehicle much faster, for that comfort, that value, it's typically the most expensive charging per kilowatt hour. Charging connectors are the devices that connect the charging station to electric vehicles. Early on, the US electric vehicle industry standardized its charging infrastructure around a 5-pin architecture. It was used for level 1 and level 2. When level 3 came around, 2 extra pins were added to the original 5-pin architecture, and that worked fine. However, Tesla, a big stakeholder in the US EV industry, went its own way and created its own charging connector. This was specific to Tesla vehicles. Also, Tesla owns and operates several fast DC charging stations around the country. But because the charging infrastructure or the charging connector was different, other car manufacturers' vehicles were not able to take advantage of the Tesla charging stations. There were adapters available, but increasingly, other companies are now using Tesla charging architecture, and we will see this architecture increasingly frequently in other vehicles. For example, General Motors has ditched the 5-pin architecture and started adopting Tesla charging connector in its vehicles. Another old charging connector was CHAdeMO. It's mostly found in uh, Nissan Leaf cars, for example. It's of Japanese origin, which literally means charging on the move. However, with standardization of charging connectors in the US, one may not be seeing that connector very much in the times to come. Let's discuss how much does it cost to charge an electric vehicle. The cost comprises of two different factors. One is the cost of electricity itself. The cost of electricity varies during day and is actually cheaper during the night when the demand for electricity is low. So it always makes sense to charge the vehicle during the night. The second component is the rate at which an electric vehicle can be charged. If a vehicle can be charged very quickly within an hour or two, there is a value to it, and DC fast charging stations actually charge for that service that they provide. So as you can see in this table, if one charges a vehicle at home during the night, the cost of electricity around the country on an average is about 10 cents per kilowatt hour. And to fill up a 120 kilowatt electric vehicle will cost only $12 for a 300-mile range. On the other hand, if one uses a Tesla supercharger, they typically charge 45 cents per kilowatt hour, and it will take $54 to charge the vehicle fully. However, it will take only a couple of hours, and that's a service which has a value. An equivalent gas car will take $48 to be filled up for the same 300-mile range. About 3% of all vehicles in the US are 100% electric by now. This number is expected to increase. Therefore, EV charging business makes a lot of sense. However, before investing money in an EV charging business, like any other business, one must consider several factors. The site preparation part of an EV charging business is particularly important because a high voltage cable needs to be drawn from the grid point to the EV charging station, and therefore safety issues are of paramount importance for an EV charging site. Ongoing maintenance, insurance, and physical safety of assets are also important because most of the times the assets themselves are at remote locations without any human monitoring. Success, of course, depends on number one issue, which is the location. A location which is accessible from many different directions and is accessible 24 hours a day so that a number of people can come increase the revenue by charging their vehicles there. The ingredient that goes into the cost of EV charging business is electricity. If one can source electricity cheaper, that will increase the profit. In addition to all these basic services, one can increase the attractiveness and therefore the profitability of the business by providing a safe and well-lit place, restrooms, Wi-Fi, and of course food services, because many times, just like a gas station, the profit margin on food items like a mini mart are much higher than the sale of gas, or in this case, sale of electricity at any given time. And of course, if when one can scale the system, that will increase the profitability. I hope you enjoyed this session. Thank you for listening.